Now we're going to be starting guided practice 5.3, and the objective for this practice is determine if triangles are congruent using various congruent criteria. Now let's review the ones that we've looked at so far. So two triangles are congruent if corresponding sides are congruent. So we've got our side criteria. Two triangles are congruent if a corresponding side, angle, side are congruent, or if a corresponding angle, side, angle are congruent. If we have side, angle, side, then we've got an included angle. Okay, and if we've got an angle, side, angle correspondence of congruence, then we've got an included side. Now we're going to take a look next at an example of what is not a triangle congruence criteria. Before we go on to that, let's answer this first question here. If triangle ABC is congruent to triangle DEF, what can be concluded about their corresponding parts? And what we conclude is that if two triangles are congruent, then their corresponding parts are congruent. Okay, if two triangles are congruent, then their corresponding parts are congruent. So that means the parts could be sides, side lengths, or angles. So let's go ahead and let's go on to this example that I said was going to show a criteria that we cannot use for congruence. Use a ruler and a protractor to measure the following. So we've got triangle A, we've got length of AC. Let's measure that. Length of AC here is 3 inches. Okay. Length of BC is going to be 2 inches. And the measure of angle A is going to be pretty close to 40 degrees, right? I'm just going to say 40 degrees. Okay, let's go ahead and make these measurements on the second triangle. We need to know the measurement or the length of RT. That's also 3 inches, right? Okay, RT is 3 inches. TS. TS is 2 inches. And the measure of angle R is going to be about 40 degrees, right? Okay, so we still have 40 degrees there. So let's mark off corresponding sides and angles. AC is 3 inches and RT is 3 inches. So this side corresponds to this side. BC is 2 inches and TS is 2 inches. So this side corresponds to this side. We can put double marks there. And finally, the measure of angle A is 40 and the measure of angle R is 40. Okay, so we've got corresponding congruent parts marked. And what criteria would this be then? We have an angle, and then if we just kind of go in a clockwise motion, we see we've got a side and we've got another side. So we've got angle, side, side, sometimes also called side, side, angle. You can go either way. And on the right, we've also got angle, side, side, or side, side, angle. Okay, so we've got angle, side, side criteria here. Does that mean that the two triangles are congruent? Well, let's go ahead and take some patty paper, try tracing the first one, and see if we can fit it over the second one. Okay, there's our first triangle, and now let's see, is there anything we can do to get this triangle to fit onto the second one? Let's try that. Let me try that. It doesn't seem to work. I can get the sides lined up, but the triangles don't overlap. Let me try this down here. Again, I can get the sides to sort of line up, but the triangles don't overlap. Let me try flipping things over. Flip over the patty paper. Keep trying. There we go. No, yes, yes, no, no, not overlapping, not overlapping. Can't seem to do it. I can't seem to get it. No matter what I do, I cannot get the two triangles to overlap. Why is that? Okay, and it's something to do with what congruence is all about. We've been saying that congruence means that you can put one triangle on top of another, but it also implies two things at the same time. A triangle is congruent to another triangle, or I could say two triangles are congruent if they have the same shape and size. Because that's really what it means when we can take a patty paper tracing and put it right on top of another triangle. It's got to be the same size and the same shape as the first triangle. In this case, we've got two triangles. You could see the shape is different. Okay, even though the size is pretty close, the shape is different. For example, here we've got an obtuse angle, right? This angle B is greater than a right angle, and in this triangle, we don't have an obtuse angle. These are all acute angles, just from looking at them. So obviously the shape of this triangle is different from the shape of this one. So they're not congruent. We have to say that triangle ABC is not congruent to triangle RST. Okay? Even though we had angle side side. So we can also conclude from this, because we have here a counterexample, by this counterexample, we know that side-side angle is not a triangle congruence criterion. Okay? I want you to also know side-side angle can also be referred to as angle side-side, but out of politeness, we often use side-side angle instead of angle side-side. Okay, it's just a kind of a thing that we look at angle side-side, and it reminds us of something that we don't think about in math. Okay, so list 3 ways you can prove triangles congruent. Let's review our criteria. We've got side, side, side. We've got side, angle, side. And we've got angle, side, angle. Those are some of the ways that we can prove triangles are congruent. What are 2 ways that we've seen so far that you cannot prove triangles being congruent? Angle, angle, angle. Okay, we did that in the last lesson, as well as what we did today, side, side, angle. Okay, so angle, 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 or side, side, angle are ways that we can't prove 2 triangles being congruent. Okay, let's move along to a couple of other facts that we know already, but are going to be important as we move forward with this lesson in terms of what we are going to use as justifications for some of our triangle congruence proofs. And I'll continue this on the next lesson.